Hello and welcome to lesson number 6. This is the first lesson in Unit 2B in our grade 10 academic math class. This is angles of elevation and depression. So this is the continuation of our unit on trigonometry. As I said in some of the earlier videos, the second half is really dedicated to expanding our understanding of triangles past 90-degree triangles or right angle triangles into all the different triangles you might encounter. With that being said, the first lesson, angles of elevation and depression, is a right angle triangle style question. So let's talk about angles of elevation and angles of depression. The angle of elevation, so I'm just jumping in right here. The angle of elevation is the angle between the horizontal and the line of sight up to an object. So what I want to point out is that what I've got highlighted here, and you may want to pause to write in some of this information or copy it down just onto a blank page. Angle of elevation is, so here's our observer, there's the person, and they're looking straight out, and then the angle of elevation is the angle up to the place where they are looking for something. So angle of elevation is straight out, horizontal, and then up. That stands in contrast to the angle of depression, and the angle of depression takes that horizontal line from our observer, so there's our observer. From them it goes straight out horizontal, and the angle of depression is from that angle down, following the line of sight to whatever object you've got going on here. So angles of elevation, angles of depression, I don't know why this is, but in my experience, people's understanding of angle of elevation tends to be very good, and it could be because we're used to being on the ground looking up at things. Angle of depression is a little bit more complicated for people. However, if we remember that all the angles of elevation and depression start with a horizontal line from the point of observation, hopefully that will help you make sense of what we're about to look at. So I have 3 examples here, and the first one I've already worked out. So again, why don't you take a pause here, copy down this question and its solution, and then we'll talk through it when I get back. So hit pause here. When you're all done, come on back and we'll talk through it. Okay, you're back. It reads, an observer on the top of a radar tower measures the angle of depression to a buoy on the water to be 28 degrees. If the observer is 40 meters above the water, how far to the nearest meter is the buoy from the base of the tower? So let's take a look at our actual drawing. So here's our observer hanging out on top. They've indicated the angle of depression down to the buoy in the water is 28 degrees. Now labeling that is probably the hardest part of this whole question. And if we remember that the angle of depression starts from a horizontal line coming out from the observer, and then the angle of depression goes down to the line of sight, down to the buoy on the ground, or I guess in the water in this case. So that's where our 28 degrees shows up. The other piece of information we're given in the question is that the observer is 40 meters above, whoops, that was an eraser. It's 40 meters above the ground. So we have 40 meters here. Those are the pieces of information that we've been given. And what you'll notice is in this drawing, we've actually created 2 right angle triangles. We've created the one that's down here. Let me change up my color scheme. We have this right angle triangle here. That's one of them. But we also have a right angle triangle here as well, if you can imagine it sort of floating upside down in space. It doesn't really matter which of these 2 right angle triangles you use. They both work. I think, again, most people tend to feel a little bit better if their triangles have their base kind of on the ground. So what does that mean? With that being said, it means that this 28 degrees here, using our angle properties, is also going to be, let me just change up my color scheme, it's also going to be 28 degrees down here. Essentially what that means is our angle of depression down to an object is the same as the angle of elevation from the object up to the observer. This follows the Z pattern that we learned in grade 9. So it makes sense. There's a basis for this to work. So we've got these 2 triangles. We just need to figure out exactly what piece of information that we want and then what piece of information we have. So what piece of information do we have? Well, we have the height of the observer, and the height of the observer is 40 meters. The one we want is the distance from the buoy to the tower. So that's this piece just right down here. I'm kind of making a mess of this drawing here with all my highlighters. Nonetheless, we're after that. Now, In this example, the way I've worked it out, I have chosen angle 62 degrees to be my reference angle. So from the angle 62 degrees, the side across from it is the opposite. That's the side that we want. And the side beside it is the adjacent, the one that we have. So which trig ratio uses opposite and adjacent? It's going to be tangent. So we've set that up over here. The tangent of 62 degrees is equal to the opposite, which we don't know, over the adjacent, which is 40. We set this up to cross multiply. We have 40 times tan 62 degrees equals a times 1. And then we are going to do the calculation 40 times tan 62 degrees. It will equal approximately 75 meters. Again, we're calculating this based on the instruction to round to the nearest meter. And then because it's a word problem, it requires a therefore statement. So therefore, the distance from the buoy to the tower is about 75 meters, period. Whoops, that's a highlighter. Period. There we go. So that is a first worked example. We have 2 more in the question here. Let's have a look at those. We'll start always with a drawing to sort of get our feet under us, and then we'll start doing some calculations. So example number 2 says, at a point 50 meters from the foot of the dinosaur, the angle of elevation to the top of the dinosaur's head is 70 degrees. Find the height of the dinosaur to the nearest meter. So let's sketch a bit of a triangle onto this thing. So we've got this height here, we have a point over here, and we have an angle of elevation. One of the assumptions we make in questions like this is that this vertical line that we've drawn in front of our dinosaur is going to be at 90 degrees. That is a fine assumption to make. There's no problem with that at all. We know that the point of measurement, which is over here, is 50 meters away from the foot of the dinosaur. And what we want to find is the height of the dinosaur. The last piece is the angle of elevation is going to be 70 degrees. So we have ourselves a triangle. Let's start now labeling a reference angle and then all of the sides of this triangle according to the reference angle. So if this is our reference angle, the hypotenuse is the side across from the 90. The side across from our reference angle is the opposite, and the side beside our reference angle, or the only side that's left, is the adjacent. So what is it that we want in this question? Well, the thing that we want is the opposite. The thing that we have is the adjacent. So which trig ratio uses opposite and adjacent? It's going to be tangent again. So we are going to set this up. We are going to use the tangent of our reference angle of 70 degrees is equal to the opposite value, which we don't know, over the adjacent value, which is 50. We'll set this up here to cross multiply. We have x times 1 equals x, and we have 50 times the tangent of 70 degrees. And now we just do this calculation. Again, we're being asked to round to the nearest meter, so let's just pop this into our calculator. 50 times the tangent of 70 is going to equal 137.3, so 137 meters approximately. And again, because this is a word problem, we need a therefore statement to sum it up. So therefore, the height is 100, or is about 137 meters. And there is our therefore statement. All right, we're looking great. Let's get one more of these under our belt before we head to the homework. So we have example number 3. The angle of depression to a disabled ship from an approaching helicopter is 55 degrees. If the helicopter is 500 meters above the level of the water, what is the horizontal distance from the helicopter to the ship? So again, a couple things here. They've asked us for the horizontal distance, so we're ultimately going to be finding not the direct path from the helicopter to the boat, but a horizontal distance instead. Let's get some triangles happening here. So what we have is a sight line going from our helicopter, and then an angle of depression that goes down to our boat. So this angle of depression down to the boat is 55 degrees. So let's pop that in, 55 degrees. We know that the helicopter is 500 meters above the water, so let's draw that in. There we go. Pull that up there. So we know that this is 500 meters above the level of the water, and we're being asked to find the horizontal distance. Now, as I said before, what I'd like us to be able to do, oops, didn't work out there. What I'd like us to do is maybe look at the other triangle this time again, and recognize that we actually have a triangle that runs like this, that also has a height over here of 500. And using those angle properties that we just talked about, we have, oh, let me draw my 90s in here. We also know that this angle of elevation from the ship up to the helicopter is 55 degrees using the Z pattern. So this time let's use the lower triangle to help us figure this out. The first time we used the upper triangle, now we're going to use the lower triangle. So let's grab a different color and let's start filling stuff in. So here we have a reference angle at 55 degrees. The side that we do have is the one across from it. It is the opposite. And the side that we want is the one beside it. That makes that the adjacent. So which trig ratio uses both opposite and adjacent? That's once again going to be tangent. So let's fill this out. We know that the tangent of 55 degrees, 55 degrees is equal to the opposite, which is 500, over the adjacent, which we don't know. And let's put that over 1. Let's set some cross multiplying up here. We are going to have x times the tan of 55 degrees equals 500. How do we get that x alone? We divide both sides by tangent of 55 degrees. Then we have x equal to approximately, what are we rounding to this time? Doesn't really say, horizontal distance, so let's, yep, it doesn't say, so let's go to 1 decimal place. And we are going to put this into our calculator. So we have 500 divided by the tan of 55 degrees, and that's going to equal 350.1. 350.1 meters approximately. So let's get ourselves a therefore statement to finish this up. Therefore, the horizontal distance is about 350.1 meters. And there we go. That is our therefore statement. We've taken care of it. This is the end of the lesson. This one's based mostly on word problems, or exclusively, I guess, on word problems. I do want to point out that question number 12 from your homework asks you to record your eyeball height here. We would normally do this in class. If you want to skip that question, number 12, that's fine with me. If you want to record your eyeball height and just include it in the question from the homework, I'm happy if you do that too. So good luck with the homework. As always, if you have any troubles, reach out to me via email, reach out to me in the classroom in person, or you can reach out to me via the group chat that we're going to have going on every day. Good luck with the homework, and we'll see you in lesson number 7.